Good morning, guys. So I told you yesterday that I would post how to do all of these interpreting data practice problems, and sorry I'm a little late on that, but today you don't have an assignment, so therefore I am going to go through this and show you exactly what you needed to do for each problem. All right, so stem and leaf plot. The first problem, the question is asking you how many pumpkins weigh more than 10 pounds. Now that's where you're going to use this stem and leaf plot to try to figure out, all right, how many numbers are bigger than 10. And remember, the key tells you whatever number is on the front side, and then combined with one of the numbers on the other side makes your number. So basically what I'm going to look for is where is the start of a number that's bigger than 10. Now if I was thinking of that, a 10 would look like a 1 with a 0 on the other side. Now, so I want to look here in the 10 spot where there should be a 1, and I don't even see a 0 on the other side. So what this number right here means is that is the number 12. 12 is bigger than 10, and I want to know how many pumpkins weigh more than 10. So basically, what that means is that every single one of these numbers from here down weighs more than 10 pounds because I'm starting with 12. So all I have to do is count up the numbers, like how many leaves there are, and that will tell me how many pumpkins weigh more than 10. So I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and 13. There's nothing there, so I don't count anything. So 13 pumpkins would weigh more than 10 pounds. There is actually only 2 pumpkins, just the number 6 and the number 8, that weigh less than 10 pounds. All right, now I wanted you guys to find the mean, median, mode, and range. A way that you could have done that is you could have taken these numbers and listed them out in order. It's already in order for you, and that's sometimes an easy way to be able to just see what it's saying. So what I'm going to do over here is I'm going to list out these numbers in a list like we saw for mean, median, mode, and range, instead of it just being in this stem and leaf plot. So I've got the number 6 and the number 8. Then these are my teens. So I've got 12, 16, 18, and 18. All right, then I go to the 20s. I've got 20, 21, 23, 26, and 29. My 30s, I have 32, I have 34, I have 38. I know my list is wrapping around, and that's okay. And then I have 59. All right, so then you guys can go to finding mean, median, mode, and range, and remember you can do whichever ones you want to do first. I'm going to go with mode first. Remember, mode means the one that shows up the most, more than any other. All right, so I'm looking for any number that's duplicated. It shows up more than one time. So I see right here, I've got 18 and 18. There's no other number that shows up the same amount of times or more. So 18 would be my most common. Range is the next one I want to do because that one's always easiest. Remember, that is the highest number minus the lowest number. My numbers are already in order, so I look at my highest and lowest. So I've got 59 minus 6, and that would give me a range of 53. All right, median, my middle. Again, remember that's where I cross one off from each side until I get to the middle. And even though my list is wrapped around, that's okay. So I'm going to gently cross off one from each side. So from the end of my list and the beginning of my list. All right, then another set. So I've got 2 crossed off on each side. I have 3 crossed off on each side. 4, 5, 6, 7 crossed off on each side. If you always want to make sure you're in the middle, you can count. So I've got 1, 2, 3, 4, 5, 6, 7 on that side of the number, and then 1, 2, 3, 4, 5, 6, 7. If it matches, you know you've done a good job. So that means my median, my middle number, is 21. All right, then The mean, that's where you add up all of your numbers and then you divide it by how many numbers were in your list total. So in this, I already added them all up and my big grand total was 360. Now remember, that is not the mean. I want to know the average. 360 is not the average, that's just the total. I'm going to divide it by how many numbers were in my list. So I just count up 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So there were 15 numbers in my list. I'm going to split that grand total between 15, and my answer is 24, which means the average number in my list, or the average weight of a pumpkin, was 24 pounds. All right, a lot of you got parts of that one right. You just didn't get the whole thing right, like you missed one of the pieces. All right, so that was number 1 and 2. I'm going to slide down to the histogram. Histograms are pretty easy to look at. They're kind of like bar graphs, as you guys can see. So the histogram, sometimes the only thing is trying to figure out, like, these lines are kind of just wherever, and you don't necessarily know how many are in each category. But the first problem just says, which interval contains the most data? Remember, interval means these guys. These are my intervals. Those are my, like, different chunks of data. So I want to know which one contains the most data. I'm just looking for which one has the most. So that would be the highest bar on my graph. So I can see right now that the 10 to 14 range has the most values in it. It is the highest bar graph. So that one contains the most data. All right, then the next question says how many swimmers are on the team. Now the swimmers are broken down into these different categories based on how many laps they swam. So what I need to do is I need to look in my table and I need to figure out how many swimmers fall into each of these different categories. So when I look at this one, the 5 to 9, I'm just focusing on that because the line is exactly lined up with a number. So I know right there, 12 swimmers were in that category. I also know right here, the 20 to 24 laps, there were 3 swimmers in that. Now these two aren't exactly on the line, so I've got to kind of estimate. So there should be a 9 line that runs straight through here. So like 9 is like right there and 12 is up here. So I'm thinking like 9, 10, 11, 12. So I would say that's probably, if I estimated, around 10. And then same thing with the 10 to 14 laps. 18 is right here. So I'm thinking like, all right, like 19, 20, 21. So 18, 19, 20. There's about 20 swimmers in that category. All right, I want to know how many swimmers are on the team. So now what I'm going to do is I'm going to add up all of these numbers to find out how many swimmers would be on the team. So I've got 10 plus 12 plus 20 plus 3, which makes 45 swimmers. All right, and then I'm going to use this piece of information for that last part. So that last question says, what percent of swimmers swam more than 4 laps? So first thing I need to do is figure out how many of the swimmers swam more than 14. So up until this point on my histogram, this is that they swam 14 laps at the most. But I want to know how many swam more than 14. So only these values over here are the ones that swam more than 14 laps. So really, that's only 3 swimmers. So 3 swimmers swam more than 14 laps out of 45 swimmers on the team. So if I do this division problem, it'll give me a decimal, which the decimal is around 0.066 repeating. Now it says percent, and we kind of talked about this in class, but to take a decimal and turn it into a percent, we did back and forth. You just take the decimal and you move it 2 times. And I said round your answer on the answer key. which just you could have done like, 6.6%, or with that repeating decimal, there would be a 6 and a 6 and a 6. So on the answer key, I did 6.7% as your final estimate of how many swimmers, or the percent of swimmers that swam more than 14 laps. Okay, so those are the first page up to number 5. All right, now the second page. This one I know was a little confusing, and I apologize for this question. When I picked it initially, it seemed like it was okay, and then digging into it a little further, it's just not exactly what I wanted. All right, so you have a frequency table, which means they've counted how many students or how many books each class read during different months. These are kind of like your different months, and I know it's weird that one of the months is 0. I didn't create the question, so I'm sorry about that. All right. So you've got the same amount of months, and your class versus your friend's class. So first thing I want to do is I want to figure out which class read more books. So I just need to add up straight across my table. I want to add up how many books did my class read, how many books did my friend's class read. Now, when I do this, I do get 30 for each class. So if you said that they read the same amount of books, you're fine. Again, I'm not sure what happened with my answer key, so I apologize. All right, then it says which class had a greater mean. Remember, mean means the average. And that's where I add up all the books and I divide it by how many numbers I added together in the first place. Now again, here I'm adding up, I've got 1, 2, 3, 4, 5, 6 numbers that I added together. And for my friend's class, I did the exact same thing. Zeros still always count. Even though it's a 0, that does count as a data point. That means you really read 0 books that month. So it still counts. Now, if I do those division problems, 30 divided by 6, sorry about that, 30 divided by 6 is 5. Again, those both look the same. So if you thought, you know what, those both look the same, you're fine. Now, the one that you definitely can figure out is which class had a lesser mode. Lesser meaning a lower mode. And this, I guess, if you're looking at this, you could have definitely like interpreted it different. Sometimes that's a hard part about interpreting data. Some people might think of things that other people aren't, or they read into different parts. So mode, remember, means most common number. If I look in my friend's class, they don't have a number that repeats. So like, my class, your class, they don't even have a mode. So they would have like no mode at all. And my friend's class, when I look there, I do see that 1 shows up the most. And I guess this one is up to interpretation for you guys. In the future, they should be a little bit more clear, but I could say, okay, which one of these is lower? This one had no mode at all, and this one had 1. The answer key I had made said your friend's has a smaller mode because it has a mode of 1, where the other one doesn't really have 1 at all. All right, so again, I apologize. 6, 7, and 8 were a little confusing. So if you had trouble with those and you did everything else pretty easily, good. All right, the last one was the box and whisker plot. And this one, in my mind, is probably one of the harder ones, depending on the question for you guys to answer. So I've got my box and whisker plot about cocoons in a butterfly tent. And the first part, number 9, says, what % of butterfly tents contain at most 10 cocoons? So one thing I just want you to think about when you are looking at a box and whisker plot is that this line in the middle that is exactly the middle of your data. That's your median. So like on the first problem when we found the median for the pumpkins, that is exactly the number in the middle. So that cuts your data in half, and you've got like 100%, and then that means you've got 50% over here and you have 50% over here. All right, so if it says what percent of butterflies contain at most 10, that means you can't have any more than 10 cocoons. So it's saying how many have 10 or less. So percentage wise, we're talking 50. So 50% of your cocoons have, or your tents have less than 10 or less. So again, when you see that line in the middle, that means that you've exactly split your data in half, 50 and 50. All right, so that one was, I know, very confusing. So if you just didn't know about that one, great job trying and putting your percent down. All right, now the next one, two are pretty easy. All right, so first of all, it says, is the data spread out more below the first quartile or above the third quartile? So that means this is your first quartile. I'm going to put 1Q, and this is your third quartile over here. And it's saying, is it spread out more above the third quartile or below the first quartile? Spread out means are the numbers spread out. So if I look over on this side, I'm looking like from this first quartile to the end, and then the opposite, I'm looking at the third quartile to the highest point. Which one is more spread out? I see that this is definitely spaced out a lot more. Oops, I'm so sorry. The top part is definitely, the lower side is definitely spread out more because it's going like from 8 to 2, where this is going from 13 to 15. So the lower, or the first quartile, has more of a spread. Okay. All right, then find and interpret the interquartile range. This is the one that I posted a picture of it, how to find that. Interquartile range, in the future, it'll be called IQR. That's where you take the third quartile and you subtract the first quartile. So those two ends of your box up here that make the box part of the box and whisker plot. So I've got the number 13 for the third quartile, and I have the number 8 for the first quartile. So all I need to do is fill those pieces in. So I've got 13 minus 8. I just do that subtraction problem. And my range, again, from one side to the other, is 5. All right, so again, I apologize. I know just teaching remotely like this without actually having you guys in class to be able to walk you through every problem is very difficult. So every one of you that tried this and gave it your best effort, thank you so much. So you don't have any work today. Today, in a little while, I'm going to post the work that you're going to do next week. Next week is going to just be a review of everything that you guys have done throughout the year. It's going to be one document, and I'm giving it to you now in case you maybe have nothing to do over the weekend. And then starting Tuesday, I'm going to have you start putting some of your answers into a Google form for that assignment. And that's going to be your only assignment for the entire week other than answering the problem of the day. You can get a jump start on it if you want. If one of the days over the weekend is a little rainy and poopy and you want to do that, that's awesome. If you didn't do any of this work this week, give it a try. That would be amazing. So I'll be on my computer all day until like 5 o'clock. That's usually when I check out. If you email me after that, I'll get back to you as soon as I can. But I'll be available for questions that you've got. All right, good luck. I miss you guys, and I hope you have a great holiday weekend.